This is one of the most important topics in class 10 maths. Today, we will be learning how to find the zero of a polynomial. Before that, let us understand what a degree of a polynomial is. The degree of a polynomial is the highest power on the variable term. For example, in this polynomial, the degree is 1 because the highest power on the x term is 1. In this one, the degree is 2 because the highest power is 2. Similarly, for a cubic polynomial, the degree would be 3. So to find the zero of a degree 1 polynomial, we can use a simple algebra method. As you can see over here, we have a polynomial with the degree 1. We move 2 to the other side and simply solve this to get x is equal to 1 by 2. So the zero of a polynomial basically means any value of x that satisfies the equation. Over here we can verify that this is the zero of a polynomial by just inputting the x value that we've got here into this equation. Putting half as the value for x, we get minus 4 into half plus 2 is equal to 0. We can cut the 2 and 4 to get minus 2 plus 2 is equal to 0 and 0 is equal to 0. Let's try finding the zeros of this polynomial. To find the zeros of this polynomial, we need to convert this into the general form. We can take 15x to the other side and minus 2 to the other side. We can simplify to get minus 2x is equal to minus 2 and x is equal to 1. We can also check the answer if it's right by plugging x equal to 1 into this equation, and we will see that it holds true. Moving on to the second degree of the polynomial. To do this, we have many methods. One is the factorization method and other one is the quadratic formula. Within the factorization method, we have two subparts where we can split the middle term or we can complete the whole square. You have learned how to split the middle term in class 9. We're going to do the same thing here. As you can see that the degree is 2. So we split the middle term into minus 2 and minus 3. Take x common in the first part and minus 3 common in the second part. And we simplify to get these factors. Now we see that we have two linear polynomials. Now if you imagine that any one of these becomes 0, then we can say that the whole product becomes 0. So either x minus 3 is equal to 0 or x minus 2 is equal to 0. So let's solve for both of them. We can put x minus 3 is equal to 0 and we get x is equal to 3. And we can solve x minus 2 is equal to 0 to get x equals 2. Similarly, I hope you can do this one. I'll give you a second to do it. Pause the video. I hope you have got enough time. Here we can see that we have 4x minus 5 as one factor and x minus 1 as the other factor. So let's solve for both of them to be 0. So if 4x minus 5 is equal to 0, we have x is equal to 5 by 4. And if x minus 1 is equal to 0, then x is equal to 1. Now the other method of factorization again is the completing the square method. We have learned this in grade 9, so I'm not going to spend too much time on this. X squared plus 6x plus 9. If you can intuitively see that this is equal to x squared plus 2 into 3 into x plus 3 square, you can see that this is a square plus 2ab plus b square. And now because we're in grade 10, we know that this is equal to a plus b whole square. And we can simply write this as factors again and solve for the answer. Now you see that in a degree 2 polynomial, we're getting two answers and also one answer. What's happening? Basically, to understand this, we need to look at the graph of the polynomials. The graph of x squared minus 5x plus 6 looks something like this, where it's cutting this point at 2 and this point at 3, which is the answer that we got over here. When we say that this is equal to 0, we mean that y is equal to x squared minus 5x plus 6 is equal to 0. So when y is equal to 0, the x-axis is where it cuts. And we can see that x equals 3 and x equals 2 are the point at which it cuts the x-axis. So we can derive this graph. But when we look at the graph of x squared plus 6x plus 9, we see something like this, where the only one answer that we're getting is x equals minus 3. Similarly, you could also think about a graph in which it does not cut the x-axis. Something like this, or like this, or like this. All of these are graphs of equations which have no real roots. We will get to that in a different video. So you may have seen that the maximum amount of zeros in a polynomial depends on the degree of the polynomial. Like when we have the degree of 1, the amount of zeros that we're getting is only 1. There's no other value of x which satisfies this equation. But when we see the degree is 2, we can see that it has a maximum of 2 answers. Similarly, for 3, there will be 3 maximum roots, 4 will be 4 maximum roots. Now that we have seen the factorization method, let's move on to the quadratic formula. The quadratic formula is also called the Sridharacharya's formula, and it looks something like this, where b is the coefficient of x, a is the coefficient of x square, and c is a constant term. If you want me to derive this formula, I can do it in a different video. Please drop it in the comments. Say the question is something like this. Find the zeros of p of x, which is equal to x squared plus 2x plus 1. So the way we would do this by using the quadratic formula is by first identifying all the coefficients. Here we can see that b is equal to plus 2, a is equal to plus 1, and c is also equal to plus 1. So using this, we can plug all of these values into the quadratic formula. Now we can just simply solve this by using simple algebra. We know that the root of 0 is just 0, so we derive minus 2 by 2, which is equal to minus 1. So can you try to guess the graph of this equation? The graph of this would be something like this. I think that is all for today. If you have any other doubts, please leave them in the comment section. I will get back to you with a video. If you enjoyed my explanation, please subscribe and like the video. I hope to see you in the next video. Thank you.